So this one is a problem about two-dimensional trigonometry, and for this example we are going to talk about the area of a triangle and also the area of a sector. So in the given diagram we can see that there is a triangle ABC and also a sector BDC, such that A, B and D are lying on the same straight line. So if we try to consider the sector BDC, as we are given that the sector has the center at B, that means BC and BD are also the radius of this sector. So as we are given that BD is equal to 3 centimeters, that means at the same time BC would be 3 centimeters as well. And also we are given that AB will be equal to 3 centimeters. And the area of the triangle ABC would be 27/4 cm squared. And also we are given that the angle ABC is an acute angle. And I try to denote this angle by theta, and this would be helpful for our working in part A. So in our part A, we are going to find the size of the angle ABC. So in part A, we can consider the triangle ABC, and as we are given that the area of this triangle would be 27/4 cm squared. Then, based on the combination of the information given, we can see that we know the size AB and BC. And also, the unknown angle is between 3√3 and 3. So based on this combination, we can try to have a look at this formula. That is, the area of the triangle equals to 1/2 AB sine theta, where theta is the angle between A and B. Also, this formula can be found from the formula book. So based on this triangle, we can try to consider AB to be the small letter A, and also BC would be the small letter B. Then we can try to use 1/2 times the length AB times the length BC times sine angle ABC will be equal to 27/4. And as we are given that BC and BD will be the same due to the nature of the radius, therefore we will have BC equals to 3 as mentioned before. So we have 1/2 times 3√3 times 3 times sine angle ABC, which will be equal to 27/4. So in my working, I try to use the notation angle ABC, but then in my draft here, I try to use the angle theta. Both of them are okay. Then we have 1/2 times 3√3 times 3 times sine angle ABC, which is equal to 27/4. And then by making sine ABC to be the subject, we have sine angle ABC, which is equal to √3/2. And for sine ratio, when we are going to solve sine theta equals to √3/2, then we can try to consider this one. For this sine ratio, we can try to consider this triangle. So when we are going to consider the reference angle 60 degrees, its opposite side can be √3 and the hypotenuse will be 2. So from this triangle, we know that sine 60 degree would be equal to √3/2. Then in this situation, we will have the angle ABC equals to 60 degrees. And then in part B, we are going to use the result from part A to find the size of the angle CBD. So in the diagram, I try to use a question mark to denote the angle CBD, and we are going to find the value of this angle. So if we try to look at the relationship between the angle theta and also the question mark, we can see that those two angles are the adjacent angles of each other. So for this part, we can try to consider this diagram. As they are adjacent angles of each other, we have the angle ABC plus the angle DBC, which will be 180. So in this situation, DBC would be equals to 180 degrees minus 60 degrees. And then we will have the answer 120 degrees. And then in part C, we are going to find the exact area of the sector CBD. So as we are going to find the exact area, then in this situation, we are going to express the answer in terms of pi. So from the result of part B, we know that the angle CBD is 120 degrees, and the radius of this sector will be equal to 3. So as we already have the angle subtended by the sector and also the radius, then we can try to consider the use of this formula. A equals to pi r squared times theta over 360 degrees, where r will be the radius and theta will be the corresponding angle subtended by the sector. Then in order to use this formula, we can try to replace r by 3 and then replace theta by 120 degrees. So we will have pi times 3 squared and then times 120 degrees over 360 degrees. And then we can try to simplify the fraction 120 over 360. That will be 1 over 3. And then 3 squared is equal to 9. 9 and 3 becomes 3 and 1. So in this situation, the answer will be 3 pi cm squared. Before the end of this video, I would like to give one more hint for AI higher level students. As for higher level syllabus, as the theta can be in terms of radian, then in that situation, we can try to use the another formula that is also the area of the sector with the radius r and the theta in radian.